Hey guys, so in this video I will be talking about a concept known as multithreading. To explain the concept of multithreading, I will be taking the example of a busy mom. Now say that this busy mom needs to send her kid off to school. So she prepares the breakfast for her kid. Once she prepares the breakfast, her kid will start having his breakfast. So while this kid is having breakfast, the kid's mom will be free. So in his free time, the mom can do some of the tasks like doing some of the household chores like running the washing machine or something. After she runs the washing machine, she can send her kid off to school. So whenever she finds a free time gap, she can do some of the task, and that is what multithreading is about. And in this video we will be running a program in Python which uses multithreading. Now right now on the screen, I have a simple program which does not use multithreading, and we will calculate the amount of time it takes to execute this program without using multithreading. And we'll also use multithreading after some time, and we'll see how much time it takes. So naturally, while using multithreading, the program should take much less time as it makes use of all its free time. This free time is also known as the idle time of the CPU. Okay, so let me just walk you through this code. I have just imported time over here, and this is an array containing numbers 1 to 10, and this is a simple function find square which calculates the square of each number in this array. And I have also added this time.sleep of 0.1, which means that this program will sleep for 0.1 seconds over here, and I'll explain later why I added this line. Similarly, the find cube function will find the cube of all the numbers in this array, and in this function I will be calling these two functions, and I'll finally be calling the execute without threading function. And over here in the execute without threading function, I define the start time and I define the end time, so that I'll be able to calculate the amount of time taken for this program to get executed, which will be end time and start time, the difference between both of them. So let's run this program. So as you can see here, it first calculated the square of all the numbers in this array, and then the cube of all the numbers in this array, and the time taken for this program is 2.01 seconds. You can also notice something over here. In the find square function, this program sleeps for 0.1 seconds, so in the 0.1 seconds it does nothing. Similarly, in this find cube function, the program again sleeps for 0.1 seconds and it does nothing. But when we use multithreading, in the 0.1 seconds in which the program sleeps, for example in the find square function, when the program sleeps for 0.1 seconds, it can move on to the find cube function and execute this function. And again the find cube function, it will sleep for 0.1 seconds, so that would be a free time gap, and in this time gap it will again execute the find square function. So in this way our program will become more time efficient. So that is why multithreading will take less time than a normal program. So over here I'll be defining another function which will use multithreading. So execute with threading. Before this, you must first know what a thread is. A thread is nothing but a task. For example, executing the find square function would be one task or a thread, and executing the find cube function is also a thread. So we need to define two threads. One is the find square function and the other one is the find cube function. So t1 equals threading dot thread of target. So target is the name of the function which should get executed. So the first thread would be the find square function, and you need to pass the arguments. The first argument would be the array which you need to pass to the find square function, and if you want multiple parameters or arguments, you can just pass them over here. Similarly, T2 will be threading dot thread, and of here the target will be the find cube function, and again the arguments would be the array. Alright, so now we have defined these two threads. So what we have to do now is to start these two threads. We need to run these two threads. For that we need to type t1.start and t2.start. So now these two threads will start getting executed, and now we need to add two more lines of code, that is t1.join and t2.join. Now what this join is saying a program is it is telling a program that it is telling a program for it to wait till the t1 thread, that is define square function, in the t2 thread, that is define cube function, to get executed. So once these two functions or these two threads get executed, it can move on to the next line of the program. So after t1.join and t2.join, both the functions will get executed. Now if you want to find the time for this program to get executed while using threading, you must again declare a variable which contains the starting time, so time.clock, and also the end time, which will also be time.clock. And let's print the time taken over here. So time taken to execute the program with threading is end time minus start time. Okay, so now we need to call the execute with threading function, and we are good to go. So I saved it, and we can now execute this program, can run it. Okay, so now as you can see, the program without threading, when it is executed, we can see that first it found all the squares and then all the cubes, and when threading was involved, it first found the square, then it slept for 0.1 seconds, and then it moved on to the cube function to find the cube, and then again the cube function slept for 0.1 seconds, and then it went out to the square function to find the square of the next number and the cube of the next number, and so on. And that is why the program without threading took 2 seconds and the program with threading took only 1 second. So the amount of time taken by the program without threading is almost twice as the amount of time it took with threading. So that is what I wanted to show you in this video, how threading can be used. Since this is a very simple program, I had to cause a delay over here using the sleep function, but in more sophisticated programs there will be some idle time which you can make use of by using the concept of multi-threading. So thank you guys, that was all about this video. If you like this video, please give it a thumbs up, and please share this video with anyone whom you think. If you have any questions related to this video, you can put them down in the comment section, and if you have not subscribed my channel yet, please subscribe my channel. Thank you.